Here we go with 22.2 notes, surveys, experiments, and observational studies. In all cases, random samples are the best way to make sure your sample is really representative of the whole population. Simple random, cluster random, and stratified that we talked about before, even when we try for a random sample, can have errors or biased results. So what we're going to talk about today is how can we make sure that our sample is not biased. So first off, sometimes when the questions are being asked on a survey, the wording may lead the person responding to think a certain way. For example, you could say something like this: do you like our wonderful new stadium? Oops, N-E-W, stadium. The way that question is phrased already has a positive tone to it. So the way that question is worded, it's more likely to get somebody to say something positive about it than to potentially say their true feelings, which may be positive or they may be negative. So that would be a biased question. Another one would be starting off something by saying, isn't it terrible? Oops, isn't it terrible that blank, 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 blank. Isn't it terrible that? Isn't it great that? Anytime you are putting some kind of a judgment call on your question, you are making it biased. There's also something called the interviewer effect. If the interviewer asks the questions in person, people may say what they think the interviewer wants to hear, or they may answer to avoid embarrassment. So, for example, if your mom asks you, do you drive over the speed limit? Because of who is asking you, you may be more inclined to respond inaccurately because you don't want to get in trouble with your mom. If I, as your teacher, were to ask you, do you like this class? You are more likely to respond with a yes because I am the one that is asking you. So the interviewer effect is actually kind of a significant thing. You really want to take out the interviewer effect. You want it to be anonymous so that people aren't influenced by who they're talking to when they make their response. There's also this thing about a non-response. Even if we try to ask everyone in our selected random sample, some will not answer. Some subgroups may be underrepresented or overrepresentative. When we email all students, not all students respond. So sometimes when you ask a question of everybody, then not necessarily everybody responds. All right, I'm going to move things so that we can get the light. Okay, I think I went the wrong way there. Almost beat the sun there. All right, so a survey measures characteristics of interest about a population using selected sample without making connections between the data. So a survey simply reports results. Simply report results. For example, how many hours do you sleep? It's simply getting some kind of results and stating the results. In an observational study, however, and this is important to note because you're going to have to tell the difference between a survey and an observational study. In an observational study, researchers determine whether an existing condition, known as a factor, is related to a characteristic of interest. For example, how does the number of hours spent studying that would be your factor, it's what you're doing, how does that relate to their test grade? To test grade. So the characteristic of interest, I'm going to call it COI because I don't want to write out that whole thing. But the characteristic of interest is how their test grades are. And then the factor that would affect that would be how many hours of studying. So does somebody who spends fewer hours of studying end up getting higher test grades or lower test grades, or how does that result? How does one affect the other? Then there's also something called an experimental study. Now, observational, I want you to think of the word observation. You are simply observing things. You are not interacting with it. You are simply looking at data from one and looking from data from another and trying to make a connection. An experimental study, or just an experiment, is when researchers create a condition by applying some kind of a treatment and seeing if it has any effect on a characteristic of interest. So again, both of these have a characteristic of interest. This one, however, has a factor. This one has a specific treatment that the person administering the study is administering or is giving to the person. So for example, you could supply students, if I wanted to take this observational study and make it an experimental study, supply students with extra tutoring. That would be your treatment. You are providing something that could affect your characteristic of interest, and therefore it is a treatment. Does it improve their test grade? So that still is your characteristic of interest. Okay? An experiment splits its subjects into at least 2 randomly selected groups to determine cause and effect. In an experiment, if you are wondering, let's say just in this classroom, does supplying students with extra tutoring improve their test grade? Well, you can't necessarily apply that treatment to the whole class and come up with a conclusion. You have to have at least 2 groups. One group that gets the extra tutoring so that you can compare it to the other group that doesn't get the extra tutoring. And those 2 groups have names. You have first off the control group, and that is the group that does not get the treatment or is not given special instructions to follow. Sometimes you'll get people, I'm trying to think, when you're driving down the freeway and they'll say, oh, do you want to participate in a new, what do they call it, a clinical trial of this particular, let's say, depression drug. If they give a drug, they're always going to have one group that gets a drug that's called a placebo. Sometimes it's just sugar. It could be just a piece of candy. I don't know. It could be something. But that group thinks they are getting the treatment. However, they're actually not. And the reason is because they want to be able to take those that are getting the treatment and compare it to those that are not. And if people know that they are not getting a treatment, they may actually respond differently than if they know they are getting a treatment. So instead, they make it seem like everyone is getting a treatment, even though only one of them has the actual effect in it. The other one is just, it's going to have no effect. So the treatment group is the one that does get the treatment or is given special instructions to follow. There may be several treatment groups with slightly different instructions. So perhaps if you're talking about that depression drug that I was talking about, maybe one treatment group gets a low dose of it, maybe one treatment group gets a high dose of it, and maybe the control group gets the placebo. So you could have multiple treatment groups getting different components with it. Okay? Both observational studies and experiments have at least 2 groups to compare and try to determine whether there is any connection to a characteristic of interest. The independent variable is the factor or the treatment applied. That's something important to know. The independent variable is the factor or the treatment applied, meaning that the treatment is something that doesn't change. The factor that's applied is something that doesn't change. The dependent variable is the result we want to know about, or the characteristic of interest. Dependent is depending on this. So depending on the treatment applied, depending on if they got the dose of the depression medicine, that affects the result. The dependent variable can change. Depending on if they got a placebo, that affects their result or their characteristic of interest. The independent variable is the treatment, the pill that they are getting. They have no control over that. What they are displaying as their result is the dependent value, or the dependent variable. When is it better to use an observational study than an experiment? Well, there's a couple things. First off, when a treatment is either unethical or not reasonably controllable. So for example, unethical. A lot of times I saw that when I was going through pregnancy. There's a lot of medications that they just don't know how they would affect pregnant women. And the reason is, if they were to do an experiment, say giving the medication to a treatment group and giving a placebo to the control group, if they find out that that medication actually does have a negative effect on the baby, then they are putting somebody in a situation that they could potentially lose their pregnancy or miscarry. That's considered unethical. It's not fair to ask somebody to participate in a survey in which you could potentially kill someone. That's not an ethical type of survey. Or making somebody do something unhealthy and then checking their health afterwards. That could be a voluntary thing. I mean, you can ask people to do that, but it's unethical to force people to do something like that. For example, several years ago when that guy did that super size me thing. It's not ethical to force somebody to get super size every time they go to McDonald's. However, if somebody's going to choose to do that, it is completely fine to get data from that if they choose to do that. But you can't force somebody to do something that could potentially put them in danger. Not reasonably controllable. That could be something if, say, your income is related to it. You can't necessarily always control your income. What if you got laid off? What if you got a promotion and your income went up? You can't necessarily control that. So that might be better to use an observational study as opposed to an experiment. All right, turning the page. So we're going to determine if each scenario depicts a survey, an observational study, or an experiment. If it's a survey, we are just identifying the characteristic of interest and explaining how we know. If it's an observational study, we're going to identify the factor and the characteristic of interest. And if it's an experiment, we're going to identify the treatment, the characteristic of interest, the treatment group, and the control group. Also, was there any information left out of the report for each scenario? So let's look at this guy. Researchers measure the cholesterol of 50 subjects who report that they eat fish regularly and 50 who do not eat. They found that those who said they ate fish had lower cholesterol. Now, hopefully it's pretty clear that this isn't a survey. You are not just asking somebody what their cholesterol is. You are actually having two groups of people and you are measuring. Therefore, it is either an observational study or an experiment. Now, the difference between the observational study and the experiment is, in order to be an experiment, there has to be a treatment applied. In this case, it doesn't look like there's a treatment applied. They're just surveying people who say that they eat fish and ones that say that they don't. The researcher themselves are not actually giving fish to people and not giving fish to other people. They're not controlling the situation in that way. So, the factor in this situation, actually I should state first off, it is an observational study. The factor would be eating fish or not. And the characteristic of interest, what is it that they were trying to find out at the end? Cholesterol levels. Okay. More info we could know. How did they choose their sample? How much lower was their cholesterol versus the people that didn't eat fish? That kind of stuff. That could be more information we would want. All right. Researchers ask a random sample of 100 people how much fish they eat. There's no real conclusion to that, is there? There's not really two groups. So what we have right here is a simple survey. There's no connections being made. There's nothing saying anything about fish to cholesterol relationship, nothing like that. The characteristic of interest in this case is simply how much fish they eat. It's exactly what they're reporting to you. All right, researchers take a group of 150 volunteers. They randomly select 50 to be fed a fish dinner daily, 50 to be fed a variety of dinners each day that do not include fish, and the last 50 ate elsewhere as usual. So they just ate whatever they had. At the end of 2 months, they measure the cholesterol of all 150 subjects. Now, this is obviously more than a survey because there's a lot more being taken into account there. So they have 150 volunteers. That sounds like it's a self-selected sample. They randomly select 50 and feed them a fish dinner daily. That's a treatment. They are specifically controlling the circumstances for those 50 people. So if there's a treatment, we now have an experiment. So we have to have a control group. And our control group would be the last 50 people who just eat as usual. 50 people eating regular. We also have a treatment group. We actually have two treatment groups. We have one group, the 50 people eating fish daily. But there's also the 50 people eating dinners, but eating no fish. And that's another treatment group because the researchers themselves are determining what they can and can't eat. So we have a group eating fish, a group eating no fish, and a group just eating regularly, which may include some fish, but not daily fish. So there's our treatment groups. What else do we need? We need a treatment. What is the treatment? The treatment would be eating fish or no fish. Oops, fish or no fish. And then finally, the characteristic of interest. What are they trying to find at the very end of the day? Well, they want to know their cholesterol level. So all of these components are all things that they're setting in place so that they can identify at the end their characteristic of interest, which is the cholesterol level. If the observational study and the experiment above both found that the cholesterol levels were lower than in fish eaters, does that definitely mean the fish lowers cholesterol? No. It might seem like there's a connection, but an observational study has no control, so it doesn't prove cause and effect. So let me write that out. An observational study has no control group, so if it has no control group, it does not prove cause and effect. Okay? Even in the experiment where the treatment is definite, there may be other unexamined factors. So in the experiment, there are unexamined factors. We call those lurking variables. Let me talk about lurking variables for a minute. Even though you have three groups, there are variables that are not being taken into account here. For example, the 50 that eat elsewhere as usual, your control group. What is making up those 50 people? Do you have 50 people that eat at McDonald's every day and get a Big Mac and large fries and a large Coke? Do you have people that eat all organic and all vegetables, maybe they're vegetarians, that kind of thing? Those would be considered lurking variables, because clearly those types of diets would affect your characteristic of interest. However, they are things that are not being controlled in this particular survey. It is controlled here and here. However, another lurking variable could be, what if you have somebody who has high cholesterol to begin with, or somebody who has low cholesterol to begin with? That could be a lurking variable. The way you would control that is you would want to make sure that your 150 volunteers all started off at a comparable level of cholesterol. Don't pick people that have super high or super low, or pick all people that have high and see how it affects them. You would want to do something to control the initial group of people that you're talking about, the initial 150, to take into account that lurking variable. What other lurking variables could be? Lurking variables are just ones in their environment or something that are not being controlled by the researchers. Another thing could be, what if somebody eats out all the time versus cooking at home all the time? That could be a lurking variable, because that can affect your cholesterol level depending on how healthy you cook or how unhealthy you cook. What if somebody got sick, got a stomach flu? That's going to affect their eating, because they might have several days where they don't actually eat. Those are what lurking variables are. All right. To see if moderate exercise has an effect on blood pressure, researchers have half their subjects walk 30 minutes a day, and the other half do no walking beyond their usual daily routine. So are the researchers instructing something? It looks like they are, which means we have an experiment. So if there's an experiment, we have a treatment. And the treatment would be walking, extra 30 minutes, or not. So the treatment of the walking 30 extra minutes, the control group would be the group not walking the extra. All subjects take their blood pressure at the same time every day. That's important, because your blood pressure is lower in the morning than it is in the afternoon. You have stressful times of the day, you have non-stressful times of the day, so that's important. That's controlling one of those lurking variables. They discovered that the average blood pressure was 15% lower for the walkers than for those who did not do the extra walking. So, here's my treatment. Let's talk about our treatment group. That is the group that walked an extra 30 minutes. Walked an extra 30 minutes. I'm trying to write fast and it's not working very well for me. So there's our treatment group. Our control group. That's the group that did not get the treatment. So that's the regular walking group. So there's our treatment group, our treatment group, control group, and coming up here, we have treatment group, control group. We need the characteristic of interest. What is the characteristic of interest that at the end of this experiment they are trying to figure out? They are trying to learn about blood pressure. More info, we could know how many people were in the sample. That would be interesting to know, because if they only sampled 10 people, that could be a huge difference than if they sampled, 1,000 people. That's a huge difference there. How many in the sample? What was their blood pressure? Did they start off with the same amount of blood pressure? There's a lot of extra information that would be helpful to know if we wanted more details on this particular experiment. So, your homework is in the textbook. In fact, I'll write it down for you here, so there's no excuses to not do it. I did put it in the locker. Move this down here. So, textbook, page 853, numbers 1 through 15, oops, not 1 through 5, 1 through 15, all. It is section 22.2, and I did put the student edition in the locker for the class. So, happy studying.